Welcome to Mission Space. This is the first time in history where a group of dentists joined forces with a team of engineers to send the message of oral health into the stratosphere. We did this because it was fun, and we did this because we felt there is an important message that we need to send to the world. And that is, to this day, 80% of dental disease falls upon 20% of kids in the United States. We did this because we now know that oral health has everything to do with total health. We now know that periodontal disease, which is gum disease, can affect the possibility of you getting cardiovascular disease, worsening your diabetes, affecting your arthritis, and for pregnant women, having low birth weight children. In this short video and documentary, you're going to learn about how we did this. You're going to learn about how we utilized a small payload containing some cameras, a hand warmer, to send a message of oral health into the stratosphere using a weather balloon. The weather balloon then explodes in the stratosphere, sending the payload back to Earth. We then utilize a GPS system to track this payload in the backyard of some random person's house. Well, I hope you enjoy this documentary, and please remember, oral health is an integral part of total health.
So the three of us go to Olin College of Engineering, and so everyone here does engineering, and we all take a really similar set of classes. So during our first year, the spring semester, everyone does a project in a class called Real World Measurements. And a really common project is the weather balloon project, so sending a balloon to space and measuring things like temperature and altitude. So Dr. Abdul found out that we had done a project like this before, and he contacted us, and we started talking to him about how feasible it would be and what sort of things we wanted to send up. So we kept similar roles for this project that we had on the last one.
Kate and I are both mechanical engineers in training, and Shane is an electrical engineer. So we sort of naturally gravitate towards what we're most comfortable with.
So that's why Daniel and I are doing a lot of the physical building of the box, and we're doing the 3D model, which is something that mechanical engineers do. And Shane is doing a lot of the testing. So for the last project, he did a lot of the electrical components and the software system. So we're all sort of sticking with what we know. Okay, so this is the 3D model that we made of the box using SolidWorks. So you can see we can look at it from all sorts of angles. And that here's the lid of the box, and we've got all the sides. And if we look inside of it, you can actually see that we've made little rectangular models of the GoPro video camera, the still picture camera, and the Spot GPS that we're using. This way we can look at how everything's going to be spaced out inside of the box, make sure we have enough room for hand warmers, because temperature is a big issue. When we get so high it gets really cold, and we need to make sure it stays warm enough so that the electronics keep working. We broke it up into 6 pieces, 1 for each side, and then we just printed them out on pieces of paper, like 1-to-1. So actually I printed them out the real size they were going to be and cut them out. Now we're at the point where we've printed out the drawings and we've traced them out on the foam. So now laid out on the foam we have to the exact size, like dimensions, and everything's at a right angle. We've got the whole picture laid out on the board.
And once we had them traced, we brought it into our mini wood shop, and we put the piece up on the bandsaw, which is just a saw that's continually passing blades, so it just can cut giant plates of stuff. And we just cut out the shapes one by one, just by sort of feeding them through the machine as it was running.
So to make this weather balloon awesome, we have to get some awesome pictures and some awesome video. So we chose 2 very specific cameras. They're going to send up, they're both going to be looking out the side, and they're going to help us get amazing pictures, very high quality pictures, and then a great video. So the GoPro is awesome. It's got a few amazing things. First off, it's meant to handle extreme conditions, and it's going to get to -40 Celsius. So we need something that's really going to be able to handle that. It's also tiny and light. When you're launching something, every extra ounce makes you go up a little slower. So you want to be as light as possible. Then the G11. This one is great because it's a very high quality camera. It takes great pictures, but it's also hackable. So that means we can put a program on this that we write on the SD card, and it'll load onto the camera and make the camera do whatever we want. In this case, just keep taking pictures every few seconds, and that way we can get pictures all the way from launch to landing. So this is our Spot GPS messenger. this is what's going to be in the balloon to tell us where the balloon is. So how this will work is we'll throw it in the balloon, and it'll just constantly be sending signals back till about 10,000 feet. Above that height, it can't actually hit the satellites anymore. So it'll just keep rising, 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 go to the top, and on its way back down, when it hits 10,000 feet again, and it'll start to send signals to us again. And at that point, we can start tracking and estimating where it's going to land, and we're going to start driving to kind of get to there before the balloon gets there, or at least get there pretty soon after it lands. Okay, so I'm outside now. I'm trying to get this to send back the first signal. If we can't get that, we're not going very far. So I'm just going to walk around for 10 minutes and find the best signal and get it to register in my computer. And that way we know that this is working for the first time, and we can start doing further tests.
Okay, so right now we are testing the fit of the pieces together because there can sometimes be errors when you're tracing and cutting.
And what we're looking for is a press fit, which means it's really tight and almost sort of stays by itself. And turns out that was successful with this because we cut it really nicely. So now we have to take it apart and glue the edges together. So we'll just use hot glue, and we have to make sure not to make it too hot or it'll melt the foam. And we just glue around the edges and assemble the pieces. So we'll do 2 pieces together and then just add on 1 piece at a time until we have the entire box.
So right now we are facing the edges of the box on a belt sander, just because when you fit together, it doesn't quite fit together. Sometimes pieces stick out a little bit. So we're just sort of sanding each of the faces one by one, just so it's a nice, snug, clean-looking box.
So the few tests we've been doing now is we've been walking around with the GPS in the box and just kind of tracking it on our website, seeing that I can find where I'm moving to. And it's done a very good job. It's accurate to about 3 or 4 feet, which is pretty incredible. We're about to have everything capable of being launched, basically, but not tested. So, like this.
I think this configuration is good.
That's where we take everything on a different day.
Yeah, it feels pretty good to me.
So the cameras both sit inside the box, and they have to be able to see out. So we have to cut holes for the camera's lenses to stick through, basically. And the way we did this was we basically set the cameras where we wanted them to be. Then we traced the outline of them on the inside of the box. And we first made a rough cut with just a regular box cutter. And we wanted it to be a nice pressure fit in there. So after we got the rough shape, we just sort of filed it out and sanded it out until it was just snugly fit in there.
So you can see the still picture camera fits right inside of the box, and the lens comes right out. And that way you don't have any obstruction of the view from the foam. So this configuration allows us to have the center of gravity right about in the middle of the box, which will keep it stable, especially when it's at really high altitude because the winds are so fast up there.
We have to attach the parachute. That's what's left on the payload side.
But other than that, I think everything is built and good to go. Sounds good.
Thank you very, very much.
All right, we'll see you in a week or 2.
Yeah, all right, see you soon. Thank you.
All right, so it's launch day, and we just got to the launch site, which is in Great Barrington, Massachusetts. It's about a 2.5-hour drive west of Boston. This is a great place to launch. It's far from the ocean, so we're not worried about hitting the water. There are lots of open fields like the one that we're in to launch from. It's perfect because when the balloon starts rising, we don't want it to hit any trees or any poles or anything like that. So this big open area is going to give us good room to work and good room for the balloon to go up.
All right, so the biggest thing we're bringing along today is a large helium tank, which is pressurized to 1,500 psi. We need this much helium because it takes a lot of helium to send 3 pounds of material to near space. We of course brought the balloon. It has a diameter at standard temperature and pressure of around 6 feet, so it's a very large balloon. And when we're inflating it, the balloon's going to want to, drift upwards into the upper atmosphere. So we also brought a net so we can hold it down. We also brought a whole bunch of hand tools just for in case anything goes wrong, we need to fix anything up. We brought some clippers for cutting the zip ties short. The zip ties are for attaching the various parts of the payload to each other and also for tying off the neck of the balloon. And we of course brought all the components that are inside the payload itself, such as the 2 cameras and the GPS tracker.
So when we got here today, the first thing we had to do was retest everything. So first we put on the GPS and just set it tracking and wait to get a signal back from that. For the GoPro, we know it's working, we know it's been fine, but we just charged it last night, Today we clear the memory card again, we get ready to go. And then for the Canon camera that we hacked, that's a lot more difficult. So we get it today, we delete all the pictures, and then you take one more test. So I take 5 pictures on auto interval, where it takes a picture every 8 seconds. And we make sure it's working again, then we delete those pictures and set it up.
We're also setting up the helium, so we're rolling the tank out to the middle of the field, and we've got the balloon and the net all ready to go.
So we called the FAA this morning just to make sure that our launch was clear with them. So one of the regulations that the FAA puts forth on weather balloons is that they have to be easily visible by radar scanners. And this is a safety measure for airplanes that might be passing nearby the payload, although it's an extremely unlikely scenario. What we've done is we've simply taped down some strips of tinfoil to our box to increase its cross-sectional profile.
So there are a couple important things to note. One is the balloon cannot touch your body. So we're gonna wear gloves, and we have a net that we're gonna use to hold it down because it's gonna try to be rising.
So before handling the balloon, we all put on latex gloves because the oils on your hands can actually damage the balloon and make it burst earlier than intended.
To set up the balloon, we basically have everyone hold a net, and one person holds the balloon up, and we start filling it up very slowly and kind of get it to the point where it can hold itself up.
We've got a regulator that you put on the nozzle of the tank, and it'll tell how much pressure is inside the tank. That gives us an idea of how much helium is left and how fast we're using it. We hold the balloon up to the nozzle of the regulator and start letting the air flow.
However, we found that the regulator was actually leaking a little bit at the nozzle. We were concerned about the pressure dropping too fast, so we took off the pressure regulator and attached the balloon directly to the outlet of the tank.
So now we're filling the balloon just straight from the tank, and it's going pretty quickly. Our goal diameter is about 6.5 feet. That's a little bit overinflated for the size balloon we have, but we want that because the payload is a little bit heavy.
56 inches, going on 5 feet. We're at 5.5 feet.
Okay, keep going.
When we were actually done inflating the balloon, we first twisted the neck of the balloon, folded it, and then zip tied it a few times, just to make sure that it would stay closed over the duration of the flight.
So now we just need to do the final packing of the payload, and we'll tie the payload to the balloon.
And then that's where my fun part comes in, and I have to go set everything up very quickly. So the GPS is easy, you turn it on and tell it to track. And so we just turn on the GoPro, cover it with its own hand warmer, and put in anti-fog inserts. And then for the Canon camera, I have to go and say, I want this quality, and I want this ISO, I want this shutter speed. Once I get that all set up, we take a few test pictures there and put it in ready to go.
And each of the components has a hand warmer taped to the battery area of the electronics because it's very cold up there, and we want to keep the batteries warm so that they continue to function. The spot, along with the hand warmer, also has some Ziploc bags as accessories because if we happen to land in a body of water, we want to make sure that we still get GPS signals.
We then close the box. We tape it closed just so when it hits the ground, it doesn't fall apart, nothing falls out, it stays in one piece.
All right.
3, 2, 1. Just hit the head.
So with everything finally tied up, we let the balloon go, on the count of 3, of course. We expect the flight will take about 2 hours, and the balloon will probably travel to an altitude of about 80,000 feet, which is close to the vacuum of space, which is pretty cool.
And we expect it to travel about 40 miles northeast from here.
So now that the balloon is going up, it's going to be able to give us a GPS signal probably for the first 10 to 20,000 feet, and then it's going to lose the signal.
All right, so we've got a signal from the balloon as it comes back down. It looks like it's going about the right speed with the parachute, so about 25 miles an hour it's coming down, and I'm guessing it's around 20,000 feet in the air, so we should be expecting it to touch down pretty soon, and we're going to get in the cars and start driving that direction to pick it up.
Now it's so soon.
How awesome would it be if it was just in the middle of the trail?
Look what it fell through. That's crazy. After 2 very scary hours, we got the signal back from the weather balloon that kept floating down and landed in the mountains in the northwest corner of Massachusetts.
So we tracked it to sort of the woods behind someone's house, and we were able to get, using a compass and using a system that would find our current GPS location, figure out how close we were to the most recent signal from the spot GPS in the balloon. And we actually were able to get pretty precise, and we got to a spot off the trail and sort of like bushwhacked to get down to where the actual balloon was.
With regards to retrieving it, we expected it to be in the woods, but it was just a suspense. As it lifted off, anticipating where it was going to land was crazy. It was amazing trying to retrieve it, especially going through the woods and really tracking it down. But the whole entire process was completely worth it.
That was amazing. I hope you enjoyed our short little video, but it's important that you understand that oral health is really an integral part of total health, and you understand that not everybody out there has access to care. At Lux Dental, we've made it a pillar, foundation of our practice, that we try to provide care to everybody. Thank you so much, and please spread the word. Oral health is definitely a part of total health.